Hello everyone! Today I'm excited to talk about something that's at the heart of software development. How we actually bring our software to life and test our ideas through prototyping. Let's break this down into parts that we can all relate to. My name is Shinamay Amandrade from BSCS 3A Group 2 and my topic is about software implementation. When you're building something, there's always a process, right? Well, software is no different. Let me explain to you. First up, we have coding. This is where the magic starts happening. Think of it like a building a house. We need to follow certain rules and standards. Our developers work together following agreed upon practices, just like construction workers following building codes. We make sure everyone's speaking on the same language, so to speak, using consistent coding styles and documenting everything properly. Now, here's where it gets interesting. Integration. Imagine you're putting together a huge puzzle. Each piece needs to fit perfectly with the others. That's what integration is all about. We're taking all these different pieces of codes and making them work together smoothly. Sometimes we do this bit by bit, testing each connection. Other times we might take a top-down approach. The key is making sure everything plays nice together. Now, let's talk about testing, and trust me, this is the crucial. It's like testing driving. I know it's like test driving a car before buying it, but we do it multiple levels. We test individually parts, that's unit testing, then how they work together, integration testing, and finally the whole system. Think of it like checking a car engine, then how it works with the transmission, and finally taking its full road test. Finally, we have deployment, the big moment when we release our software into the wild. But we're smart about it. We might release it gradually and dipping our toes in the water before jumping in. We have different strategies like blue-green deployment. Think of it like having a backup runaway and canary releases where we test a small group first. Before we dive into prototyping, let me ask, has anyone here ever scratched out an idea for an app or website, even on paper? Now, let's switch gears and talk about prototyping. You know how artists make sketches before painting a masterpiece? That's exactly what we do in software development. Let's start with low fidelity prototypes. These are like rough sketches, quick, simple, and perfect for getting initial idea across. Imagine drawing your app idea on a napkin or whiteboard. It's not pretty, but it gets the point across. You use this to quickly test idea without investing too much time and effort. Um, think about the last time you used a new app. That polished look and feel probably started as a fidelity prototype. Then we have high fidelity prototype. These are like detailed sketches artists make before touching the canvas. They look and feel much closer to the final product. They have colors, interactions, and real content. It's like seeing a 3D model of a house before it's built. You get a really good idea of what you're doing to get. Here's an interesting concept. Throw away prototyping. As the name suggests, these are prototypes we create knowing we'll discard them. Sound wasteful? Not at all. Think of it like making a rough draft of a speech. You might not use the exact words, but the process helps you figure out what works and what doesn't. Lastly, there's evolutionary prototyping. This is different. It's like building a car while driving it. We start with the basic working models and keep improving it based on feedback. It's more like how Facebook and Instagram evolve over time. constantly adding a refinement feature. Remember, the key to successful implementation and prototyping is being flexible and responsive to feedback. Whether you're writing code or creating prototypes, it's all about communication between teams member and with stakeholders and ultimately with your users. Are there any questions? Comment down below. I'd love to hear about your experience with these processes too. Thank you.
Good day, sir. My name is Belenario Salvifave of BSCS 3A of Group 2. My topic is all about software development, best practices, and code modularity. Software development best practices help ensure code is efficient, readable, scalable, and maintainable. Code modularity in particular emphasize breaking a program into smaller, independent, and reusable components. Improving maintainability and reducing complexity. Software development ay help ensure ng code para maging mas epektibo, readable, scalable, at madaling i-maintain. Code modularity ay breaking a program na magiging independent at reusable na components para mapadali ang pag-aayos at mabawasan ang komplikasyon. Writing clean, maintainable, and modular code, readable, use meaningful variable methods, name, consistent formatting, and comments where necessary. Ang usability, break code into functions, classes, or modules that can be reused in different parts of the program. And encapsulation, hide implementation details to prevent unintended modifications. Ang readability, gumagamit ng meaningful na pangalan para sa variables or methods, panatilihing consistent ang formatting, maglagay ng comments kung kinakailangan. Ang reusability naman ay hatiin ang code sa functions, classes o modules para magamit muli sa iba pang bahagi ng program. Ang encapsulation naman ay itago ang implementation na detalye upang maiwasan ang hindi inaasahang modifications. Ang Object-Oriented Program or OOP principles. OOP helps structure code around objects and classes, making it modular and maintainable. Ang key principles include tulad ng una, encapsulation, keeping a data private within a class and only allowing access through methods. Abstraction, hiding complex implementation details and exposing only essential features. And inheritance, allowing new classes to inherit attributes and behaviors from existing one. And multiformism, enabling a single interface to be used for different data types or methods. Ang OOP ay nagfi-fix ng code gamit ang objects at classes para maging modular at madaling i-maintain. Ang encapsulation naman ay keeping data private sa loob ng class at ina-access lamang ito gamit ang methods. Ang abstraction naman ay itinatago ang complex details at ipinapakita lang ang mahalagang features. Inheritance, pinapayagan ang bagong class na magmana ng attributes at behavior mula sa existing na class. Ang huli ay multiformism, allowing interface na gumamit ng iba't ibang data types o methods.
Good day, sir. My name is Romanidor from BC History. I will discuss the UI UX design prototyping. UI or user interface design focuses on the look and feels of a system, ensuring user can interact with it effectively. While UX or user experience design ensure the system is intuitive, efficient, and enjoyable to use. Ang user interface design ay tumutukoy sa itsura at disenyo ng isang sistema na titiyak na madali itong gamitin ng mga user, samantala ang user experience naman ay design na nakatuon sa pagiging intuitive, epektibo at kasiyang gamitin ng sistema. The topic of UI and UX design and prototyping is versus UI and UX principles. First is user-centered design or USD. The design should prioritize user needs, preferences, and behaviors. Next is usability testing. Testing the prototypes with real user to identify usability issues for minor implementation. Ito ay pagsusuri ng isang prototype gamit ang totoong mga gumagamit upang matukoy ang issues paggamit ng bago ng final na pagpapatupad. Next is consistency. Using the standard design elements like buttons, navigation, and colors to ensure the familiarity. Ito ay pare-parehong disenyo ng mga elemento tulad ng button, navigation, kulay upang maging familiar ang interface sa mga gumagamit. Next is accessibility. Ensuring design are inclusive like color, contrast, for readability, keyboard, and navigation. Next is feedback and affordance. Button animation and prompts should guide user on how to interact with the system.
Good day. I'm here to explain the code refactoring and optimization. Refactoring is like improving existing code without changing functionality, or meaning is cleaning up code to make it easier to read and maintain without changing what it does. The examples include renaming variables, breaking big functions into smaller ones, and etc. The optimization, enhancing performance by reducing memory usage, improving algorithms, and minimizing unnecessary operations. Means making code run faster and use less memory by improving how it processes data, reducing unnecessary steps, and using better algorithms. Number 3 is avoiding code smells, which is identifying and fixing poorly structured codes. means finding and fixing messy codes that makes it hard to read or maintain, like overly functions, repeated code, or unnecessary complexity. We see in the code the refactoring or improving code structures without changing functionality. We fix the inconsistent naming like self, author, and etc. We correct the init method to properly initialize attributes. We also improve string formatting for better readability. And we also use consistent indentation and spacing to enhance clarity. The optimization one is the logic is already efficient, but a further optimization could be lagging book transaction to reduce the redundant checks. Number 3 is the avoiding code smells, like fixing messy or unclear codes, the unclear expressions like incorrect f string, formatting in get underscore details, open and close parentheses. We also remove unnecessary conditions like sub that is underscore borrowed twice in return book. We ensured method names clearly describe their actions. By refactoring, optimization, and avoiding code smells, the code is now cleaner, easier to read, and more maintainable without changing how it works. Thank you.